Hi there once again, and welcome to another Expresso mechanics tutorial, and this will be episode 20 in the series Python Bytes. In this one we're going to be looking at Python's random shuffle method, and we'll create three slightly different scenarios that employ this. That's what we're going to be about in this tutorial, so without further ado, let's see if we can make this happen. We'll start by bringing in a cube and make it 20 by 20 by 20. And I'll also put a small fillet on it, just 0.5. We can drop this into a cloner, so hold down the Option key and drop it into a cloner. And I'll make this a linear cloner in the mode. Everything else we can leave the same. The count will make 5. We don't want our position Y to change, but we will make our position X 21 so that we get a little gap between each cube. We'll just hit O so that we can see everything. Now we'll come into our transform tab, and in the transform we'll select index so that we can see our index values for each of our cubes. Moving on from here, we can bring in a Python effector, and we can see that something has already happened. And normally with the Python effector we don't get this step effect, we would get the whole lot moving over here somewhere. So things have changed slightly, and at the moment we're in parameter control, we want full control, and we can see that things have changed there too, so there's something slightly different going on here to what normally happens as well. And we'll see what that is in a few minutes time, or a few seconds time really. If we just switch to a scripting layout, just make the window a little bit smaller, and then open in Python editor, we've got everything set up and we're ready to start doing some work. Now for those of you who are using earlier versions of Cinema 4D, and I've got the latest update for Cinema 4D here, so this is why things have changed. But for those of you who are using earlier versions, you won't be seeing a lot of this code in here and a lot of these comments. It will be different. For a start though, we'll just get rid of the loop. I always do that. We'll do that and execute, and that puts things back as they are, or were originally, I suppose I should say. Let's just get rid of that comment as well. We don't need that. Don't really need any of these comments actually. The main difference that you will see is up here things are expressed slightly differently, but don't worry about that. And down here things are expressed differently, but again you don't really need to worry about them. The only thing that is perhaps important to stress here is this line. Now if you're using an early version of Cinema 4D, the line you will have will be ma is equal to, and it will be mo data bracket dot I beg your pardon, get array brackets, and then it will be c4d dot mo data, all in capitals, underscore matrix. That's the important difference, but this line does exactly the same as this line. Okay, I'm going to comment that out, but I'll leave it there for your reference. Now this line here deals with the matrix array, but I want the color array as well. So I'll copy this, paste it in here, and say colors is equal to, and then just change the word matrix for the word color at the end. So that gets me my color array. Now if you're using the earlier version, once again we'll copy this line, paste it in here, change ma for car and matrix for color. Oops, we don't need the U, color. That's it. So that sets that up for you if you're using an earlier version. Down here, we've also got a line that we need to work with. So we'll copy this, paste it in here, because this is what updates the arrays. So we need to update our color array as well as our matrix array. So we'll type color into there and colors here, and that will do the job for us. Once again, if you're using an earlier version of Cinema 4D, you will have MoData, and it will be .set array brackets C4D dot, and it will be MoData underscore. You will have matrix, we'll put that in first, matrix, and it will be comma ma comma, and it will be has with a small h, has field. That's the old way of doing it. So to do the color, all you need to do is copy it, paste it in there, change matrix for color, and ma for car, and that will update your color array. Fabulous. So that's done, and what we'll do is comment those out because I don't need them, but again I'll just leave them there for your reference. Fantastic. So we've dealt with the sort of newer stuff that's in here. Just make sure that's correct, and we can move on from here. At the top here we need to import the random module, so we'll import random so that we've got that in, and then we can think about where we're going from here. Under here we need to add some global variables for a start, so we'll say global, and it will be trigger start underscore time, and we'll also add indexes, and they'll be our initial global values. I'm also going to add a spline, so if we come into our Python here and user data and user data, we'll call it spline and grab a hold of a spline type. We can then make this into a bell curve. So in fact, we'll just hit OK and we'll make it into a bell curve down here, I think. So if we add 3 points, we can just set these up. So at 0, 0, 1, 0, and we'll just twirl this open. 0.5 on the X, 1 on the Y for the center point, and then we can work with our tangents. We can say minus 0.25, it should be 0.25. That's fine for that. Again in here, minus 0.25, and that's fine because this is at 0.25. So we've got a nice bell curve, and we're going to use this to make our cubes raise and lower within a range mapper. So we've got that in, and we can drag the spline into our editor window. Let's take it away from there. It's in the wrong place, as it always is. And we can say spline is equal to op, and that gets our spline data in. The next variable is the ubiquitous frame variable. So frame is equal to doc.get time, get frame brackets doc.get fps, open double close, brings in our frames from the timeline, and that's all looking good. Now the next thing that we can do is think in terms of setting up the colors of our various cubes. Let's just execute that, make sure everything's okay, which it is, because an error seemed to come up in there, but it seems as if it's okay. If there are any errors, we'll soon iron them out. So let's start working with our colors. Now there are 5 cubes. So I'm going to do these with individual lines. I'm not going to use a for loop or anything like that. I don't think it's worth it. We'll just say colors brackets 0. And we'll say is equal to C4D dot vector brackets, and I'm going to say 1, 0, 0 because I want our first cube to be red, and if I execute that, I do get a red cube. Let's copy and paste. Just paste that in, and we can change this to 1, or rather 0, 1, and that will give us a green cube, but we've got it for our first cube again. We want it for our second cube. Let's just do that, and now we've got those two. Paste once again, change our 0 for a 2, and we'll make this one blue, and there we go. Change our 0 for a 3, and this time I'm going to use 1, 0, 1 to give us a pink cube, and then finally change this for a 4, and I'll go 1, 1, 0, and we'll get a yellow cube. And there we go, we've got our colours all set up, and that's working perfectly well for us. The next step that we can take is to think about what we're going to do at the beginning of our animation. So we can say if frame is equal to 0. Now, we defined indexes as a global variable. So for a start, we can say indexes is equal to, and it will be an empty list. We can also define trigger. That will be equal to 0, and start time will also be equal to 0. We can then think about where we're going next. So we can say for I in range len, and it will be matrices, and then we simply need to say indexes dot append I. So we want to collect the index values for each of our cubes. So from 0 to 4, we want them to be collected into indexes. And this is the point where we can use random shuffle. Because obviously we're going to have the index values in the order that you see them here. So numeric order, 0 to 4. If we shuffle them, we're going to move them all around. So that's what we're going to do. If we say random dot shuffle brackets indexes, that will do the job for us, and we can see that that works by printing. So print indexes. Let's just execute that, and straight away we can see that we've got 31204. So we definitely have shuffled those index values. So that's all working exactly as we want it to, and it's doing the job for us. Moving on from here, we can start to think about moving our cubes, and that's going to be our next step. The aim is to make our cubes move up and down once every second. So we'll start by saying if frame, and it will be modulo, so a percentage sign, 30 is equal to 0. So once we've counted through 30 frames, we'll get a 0, and that will trigger our next step. We can then say if trigger is less than 1, trigger equals 1. So that primes our trigger, and we can then say if start time is less than 1. Start time is equal to frame. So whatever our current frame is. Moving on from here, we can come back to this level. So if trigger is equal to 1, so if it's been primed, we're ready to start moving our cubes, or our cube, it's one cube at a time. We can then say mover is equal to, and it will be indexes, if we spell it correctly, index is brackets 0. So we want whatever number is here. And on this occasion, it would of course be our pink cube that we'd be choosing to move, because that has the index value 3. So that's what we're getting here. So we've got mover, we've got that sorted out. The next thing we need to do is work with our duration. So we know that our duration is going to be essentially, well, it won't be 30 actually, we'll make it 29. But anyway, we can say that duration is equal to, and it will be frame minus start underscore time, and that will give us a starting point at 0 wherever we happen to be along our timeline. We can then say if duration is less than, and we said just now 29 frames. And the reason that we're doing this, if we did say 30, probably get a bit of glitching in the animation. We don't want that. We want a nice smooth animation. So we'll say is less than 29. That's essential. Okay. And now we can start working with our range mapper. So we can say range underscore mapper is equal to, and it will be c4d.utils dot range map brackets duration as our input value, and our input range will be 0, 29, 0, 42 for our output range. So we want our cubes to essentially go up 42 units here, and they're 20 units in height, so it's pretty much double their height. Comma true, and then finally spline, and that sets our range mapper up. We can then think about working with a vector, and initially we need to go vectors to reals. So x will be equal to, and it will be matrices brackets mover dot, and it will be off dot x. Our y value will be the range mapper, so that's y sorted out, and then we'll copy this line here and paste it here and change the x's for z's, and that converts our vector to reals for our current cube. We then need to convert our real values back to a vector, which we can apply to the cube that we wish to move. So we can say matrices brackets mover dot off is equal to c4d dot vector x comma y comma z, and that completes the reals to vectors, or reals to vector I should say, and will enable us to move our cube. To finish this part of the code off, we can say else trigger is equal to 0, start underscore time is equal to 0, and then finally we can say random dot shuffle brackets indexes. So we're shuffling once again. And that completes our first part of this code. This is our first scenario dealt with. Let's see what happens when we give it a go. Let's see if it actually does work. See if we've got any errors. So there we go. We'll give ourselves a few more frames. Give ourselves 1,000 for what it is. And just let this run. And there we go. All of our cubes are being moved randomly by shuffling the indexes. So that's fantastic. That's one scenario that we've completed, and it's all working as it should. But let's do something a little bit different and see what happens next. It's great being able to shuffle the index values, but our cubes have remained in exactly the same positions. But suppose we wanted to shuffle the pack and actually move the cubes around. Well, we can do that too. But in order to do so, we have to create a copy of our matrices. So in order to do that, the first thing we need to do is add another global variable, and this one we'll name new_matrices. So we've defined that. And then at frame 0 here, we can set that up. We can say here, new_matrices equals matrices to create the copy. Now, in order to shuffle the pack, simple thing to do, what we'll do in fact here, we'll just comment random shuffle here for the indexes out, copy it, and I'll paste it here, and it will be random dot shuffle brackets, and instead of indexes it will be new matrices. So that will shuffle that and get that sorted out for us. Moving on from here, we need to add a line under our trigger. All we need to do is say matrices is equal to new_matrices. So there's a bit of a juggling act going on here. We create a copy of our original matrices, and then we give this copy back to our matrices here. This is the way you have to do it. If you don't, it just doesn't work. It is a bit of a strange convention, but it's just the way it is. And then to finish off, once again, I will comment this out, copy it, and paste here. And once again, this will be new_matrices. Okay, and that should be as much as we need to do. Now let's just go back to the beginning of our animation. Straight away, you can see that it's worked. The red cube is over here now, and they're all in a completely different order. Let's just run the sequence and see what happens. So we can see that we're shuffling, and it's always our cube 0 that actually moves. So wherever our red cube goes, it's always the one that's getting moved. So we've created a different scenario here. And of course, we're doing that because we're using indexes here. Mover is equal to indexes bracket 0. If we change it to 1, we'll find we'll get a different result. Let's just reset that. Now, straight away, we're getting it's the green cube. So you've got an option here to keep, you could set up a counter in some ways and change this so that you can sequence through them. That's just one possibility. So there's different things that you can do here, but it's created a completely different scenario from what we had before, which is wonderful. That's really good. So that's really nice to be able to do. Now, our third scenario, all we need to do is basically take away the comments from here, and now we're randomly shuffling our indexes and our new matrices. So we've got both of them going, and now we get a different scenario again. We're shuffling the pack, but we're also choosing a random index value, so we don't always get the same one being moved. And again, we've got a 1 in there. We can just put that back to 0 and it will still work fine. Let's go back to there, and there we go. All works perfectly well. So there you go. 3 different scenarios that use the random shuffle method within Python. And it's quite fun. And that just about brings us to the end of this tutorial, because I've shown you everything that I wanted to in this one. And as always, I really hope this has inspired you and given you some ideas for things you may be able to try out within your own projects. And if you have enjoyed the video, please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. And I certainly need the views. But anyway, that just about brings the curtain down on this one, so I'll see you very soon on the next tutorial.